So now we're going to jump into the complex number system and look at the complex number systems. So really the real number system we'll see is a subset of our complex number system. And I'm going to share my screen and we'll go through the notes on this. Okay, so I'm sharing my screen now, and so let's just talk about this. So one thing that we know with the real number system is that its square is non-negative. So if you square some number, a real number, you're always going to get back a positive number. So for example, there's no real number x such that if we squared it, we get back -1. So there's no number x such that x squared equals -1. So to help out with that situation, they introduced a new number called an imaginary unit or an imaginary number. So the imaginary unit, which is denoted by little I, is the number whose square is -1. So I squared equals -1. Oops, and if I look back further down to what they said, that is I squared equals -1. Okay. So complex numbers, we can write them in the form of A plus BI, where A and B are real numbers. The real number A is called the real part. Of the number A plus BI, and I is the imaginary unit. So when complex numbers are written in the form A plus BI, where A and B are real numbers, it is in standard form. Of a complex number. Any number of the form BI is called the not sure. Basically B is the imaginary number. So B is the imaginary part. Okay. So recall back in algebra, if you had the square root of a number, sometimes we rewrote it as factors. So let's say we had the square root of two numbers multiplied together, A times B. That's the same thing as the square root of A times the square root of B. We can break it up as two separate radicals. And so when we're looking at this first example, the square root of -49, okay. Sorry, I'm just still trying to figure out what this is. Square root of 49. So I could rewrite this as the square root of -1 times the square root of 49. We know that the square root of -1 is I, and the square root of 49 is 7. Normally you see this with the imaginary part written second, so 7I. Just want some more room. And so I'm just going to do it over here. So part B, it had the square root of -27. So I noticed that 27, it's not a perfect square, but there is a factor of 27 that's a perfect square. So we can rewrite this if it helps you. 27 can be rewritten as 9 times 3 times -1. So if we look at the square root of 9, that's 3, so I can pull that out. The square root of -1 is I. And then there's nothing, no whole number that I can square to get back 3. So root 3. So square root of negative 27 is the same thing as 3i root 3. And then part C, the square root of negative 125. So again, negative or 125 is not a perfect square, but 25 times 5 is 125, and 25 is a perfect square. So I would break it down. We can write it as 25, doesn't matter, order of multiplication, times negative 1 times 5. Pull out the perfect square. So the square root of 25 is 5. Square root of negative 1 is I. And then we have square root 5. So our answer for the square root of negative 125 is 5i root 5. So example 2, complex numbers, write each of the following in standard form. So we want to put it in the form of a plus bi. And so we want to go through and we want to simplify. And so if I'm looking at 4 minus the square root of negative 36, well, that's 4 minus the square root of negative 36 is 6i. So this is in standard form. If it asks you for the real part, that's the number not attached to the I. So this would be 4. Be careful if it asks you for the imaginary part, it's just the number in front of I. Don't tack on the I when you write that. So the imaginary part in this case is negative 6. Okay, so part B, negative 5 plus square root of negative 32. So I want to break it down. I know that there's a factor of 32 that's a perfect square. 16 times 2 is 32. Oh, wait. Sorry. Yeah, 16 times 2 is 32. So we can break this down if you wanted to as negative 5 plus the square root of 16 times negative 1 times 2. And pull out what we can. So we get negative 5 plus square root of 16 is 4. Square root of negative 1 is I, and then we have root 2. So the real part in this case would be negative 5, and the imaginary part would be 4 root 2. And then part C, 3 minus the square root of negative 25. Well, that's 3 minus square root of negative 25. This is 5i. Okay, so looking at the following, we have equality of complex numbers. It tells me that if we have a plus bi is equal to c plus di, this is if and only if a is equal to c. So the real parts are equal to each other on each side. And the imaginary parts are equal to each other. And b is equal to d. If we want to sum complex numbers, basically all you're doing is you're adding your real parts and you're adding your imaginary parts. So if we look at this, if I rewrote this, I don't need the parentheses here. My real part, right, is a plus c plus my imaginary part. So if I wrote that out, bi plus di. But notice that I could rewrite this if I wanted to, as I'm going to just put parentheses around the real part, a plus c, plus, notice I can factor out an I from my imaginary part. So I'm just adding the coefficients in front of the imaginary parts together, b plus d, and then it's all times my I. So it's just like we're adding like terms. Treat it like adding like terms. If it's an imaginary number, they're like terms, but they're both. The difference, we got to be careful because of this minus, we got to distribute that negative sign. in front of that second parentheses. And so when we combine the real parts together, it's going to be an A minus C plus BI minus DI, which is the same thing as subtracting the real parts, A minus C, and then plus subtracting the imaginary parts, B minus D, all times I. So for the example for part A, where we have 4 minus 7i, that complex number plus the complex number 6 plus 3i, just add your real parts, 4 plus 6, which is 10, and then add your imaginary parts. So negative 7i plus 3i. So negative 7 plus 3 is negative 4, and then put on the imaginary part. So minus 4i. So negative 7 plus 2, add those together. Negative 7 plus 2 is negative 5. And negative 8i plus 10i gives me plus 2i. Here I need to distribute my negative sign. So if I want to rewrite it, I have 6 minus 9i minus 3 minus 6i. So combining my real parts, 6 minus 3 is 3, and negative 9i minus 6i gives us minus 15i. Distribute the negative, we get negative 4 plus 8i minus 2 minus 7i. Combine the real parts, negative 4 minus 2 is negative 6. Combine the imaginary parts, 8i minus 7i gives us plus I. So I can't, I need to simplify part E first by pulling out or rewriting the square root of the negative number as an imaginary number. So this 5 plus square root of negative 36, that's the same thing as 5 plus 6i plus, and then 2 minus square root of negative 49, that's the same as 2 minus 7i. Add our real parts together, 5 plus 2 gives us 7. Add our imaginary parts together, 6i minus 7i gives us minus I. So adding and subtracting complex numbers shouldn't be bad. And then multiplying complex numbers, we got to be careful, and we've got to use that fact that I squared equals negative 1. Okay, so looking at the product of complex numbers, basically we would need to distribute here. If I distributed this, let me just write it on the side, A plus BI all times C plus DI. Well, A times C, that gives us AC. A times DI, that gives me ADI. BI times C, that gives me BCI. Plus BI times DI. Well, BI times DI, that gives me BDI squared. So recall that I squared was equal to negative 1. Or I is equal to square root of negative 1. Square both sides, you get I squared equals negative 1. So right here, I'm going to rewrite that as negative 1. And over here, let's pull out the I from the imaginary parts. So rewriting this, I have my real part AC. This I squared is really, I'm going to put it over here, is negative 1. So negative BD plus, and now I'm going to factor out an I from these two terms, those two middle terms that I have there. So if I pull out an I would have inside the parentheses AD plus BC all times I. So if we do the product, we get AC minus BD is the real part, and plus AD plus BC times I is the imaginary part. I would just FOIL it out. I wouldn't look at what is my AC minus BD in that case. You can, I guess, memorize it if you want, but it's just easier just to FOIL. Just recall that I squared is -1. So remember, A plus BI is a complex number in standard form. So if we call Z a complex number, A plus BI, then its conjugate, we use the conjugate a lot, the conjugate of radicals. This is denoted by, notice this bar over the Z. And it's defined as all you're doing is you're changing the sign in between the real and the imaginary. So Z bar is equal to A minus BI. So the product of a complex number and its conjugate is a non-negative real number. That is, if Z equals A plus BI, then Z times Z bar is equal to what? Well, let's show it. If Z is equal to A plus BI, we know Z bar is equal to the conjugate. So we have A plus BI all times A minus BI. This is a difference of squares. So recall, and sometimes just doing the shortcut, if you notice that you have a difference of square, let me just, I kind of don't want to use the same variables I used there. I don't know, but I'm going to anyways. If you see A minus B times A plus B, recall this is the same thing as A squared minus B squared when you FOIL that out. So the only thing that we have to be careful here, when I FOIL this out, this is going to equal A quantity squared plus B, I'm sorry, minus BI quantity squared. Well, A squared minus BI times BI, that's B squared, I squared. B squared's okay, but I squared is -1. So this is really minus B squared. Minus a negative is plus. So this would be in the form of A squared plus B squared. So if you're multiplying by the conjugate, imaginary numbers, you can just square the first term plus the square of the real part of the second term. So part A, multiplying complex numbers, 9i times the quantity 4 plus 5i. We're just going to distribute the 9i to both terms. 9i times 4, just multiply the coefficients. 9 times 4, that's 36i. Plus 9i times 5i, that's 45i squared. The I squared is -1. So this is 36i minus 45. A lot of times it's going to ask you to put this in standard form. This is not quite in standard form because it's not the real part plus the imaginary part. So if to put this in standard form, you're just going to rewrite the order. Just be careful and carry the signs in front. So this is the same thing as -45 plus 36i. So next example, all you're doing is distributing 6 times 3, that gives us 18. 6 times I, so that's plus 6i. Distribute the -2i, so -2i times 3, that's minus 6i. And -2i times I, so that's minus 2i squared. So I get 18. Notice 6i minus 6i cancels. And negative 2i squared, that's negative 2 times negative 1. So this is really plus 2, which is equal to 20. I just want you to be aware, again, real numbers can be rewritten as complex numbers. So if I was asked what the real part is, that's 20. The imaginary part, though, of a real number is 0. I can technically write every real number as a complex number in standard form, 20 plus, in this case, 0i. Okay, so time is up. I'm going to stop there. We'll finish off on complex numbers on Thursday, and we'll get into solving different types of equations. So equations with radicals in them.